to discuss, and I will discuss to you the first method of velocity analysis on how to perform the velocity analysis using resolution and composition method. But before we go into that, recap muna. Recap lang. Open ko lang yung file. Ano ba? Balik tayo hanggang vector. Okay, for vector operation, we will use vectors in representing velocities. Vector is made up of four parts. First is the length of the line. It shows the magnitude, the orientation, so the angle of inclination of the vector. Then the arrowhead to point the sense, to direction sense, and the origin or the tail to show where the point is originated from. That's vector. If we will use vector in velocity analysis, we will place it in diagrams, such as this one, space diagram, and we can incorporate the vectors by drawing the vectors in the diagram. If we will perform analysis on vectors, we can remove it from the diagram and we can perform addition and subtraction. So for addition, we have two methods. In the case of there are only two vectors, we can use the diagonal of a parallelogram and closing side of a triangle. So for the diagonal of a parallelogram, we have two vectors where its origin are the same, and we will have to reflect parallel lines from this vector to form a parallelogram. On the diagonal, in this parallelogram is the resultant or the equivalent of those two vectors. For closing a triangle, we will make a triangle using the two vectors where the second vector is connected at the arrowhead of the first vector. And once we have connected these two vectors, we will close it out with a diagonal, which looks like a triangle. Then if we have more than two vectors, we can add them by connecting the vectors at the arrowheads of the succeeding or the previous vector and close out the polygon, which starts with the original origin. And for vector subtraction, what you have to do is connect the arrowheads of the two vectors and close it out as a triangle to determine the difference. So if we, in the case that we have more than two vectors in subtraction, we subtract two at a time until we reach the last two vectors. Then for vectors, we can resolve the vectors by resolution by determining two vectors that can represent the given vector. For this one, we have to first have reference lines. So this is reference line. We have to make a parallel lines of this reference line that intersects at the end of the vector, like this one, the blue one, and their intersection points will be the end of the component vectors, this green line. And these two are now the component vectors that has a resultant of the vector that is given. And if we will write vector addition in equation form, it's simply as writing variables and the plus sign having an arrowhead at the right. So that is vector operation. Next, we had position analysis. Commercial, for the design plate number 2, I mean 1, I already gave out the instructions for that. But I'm not expecting you to perform or create the design plate already. We will be having our next face-to-face meeting on Sunday next week, and I plan to have the design plate done here at school. I will be at boiler room again, and if you want to make it, it's okay. But I'll check it on Sunday, and the deadline for submission is also Sunday. So again, Sunday we will have no official class, but we will make the design plate number one here at school. Parang inisip ko lang, magkaroon kayo ng heads up. Parang ito yung gagawin natin. Kasi pagka binigla na, kung makita niyo yung gagawin natin na design plate on that day, isipin niyo pa din eh. At least ngayon, kung may time kayo, basahin niyo muna. Tingnan niyo kung maintindihan niyo na siya para hindi naman start from zero pagdating sa mismong araw ng pagdodrawing. Also, gawin niyo na yung title block bago kayo pumasok. Nagtatanong sa akin kung meron bang size. Hindi ko alam eh. Usually, dati pag sinabi ko magawa yung title block, nagagawa na sila eh. So, basta nandun yung contents na nakalagay dun sa instructions kung anong laman dapat ng title block, yun ang nalalagay niya. Pero yung sizes, okay lang, kahit ano. Basta yung margins pare-pareho naman, nakalagay naman dun. Okay. After the vector operation, we had position analysis. This is basically understanding the positions of the parts of the mechanism with reference to a system. So we will use the coordinate system. We can use global coordinate system, which means that globally, it is known that the x-axis and the y-axis are the horizontal line and the vertical lines. We can describe the vector using this global coordinate system in polar form or Cartesian form. By polar form is by stating the magnitude of the vector and the angle of inclination with respect to an axis. So for this example, we have a magnitude of RA and its angle of inclination is with reference to the x-axis. We can also show the vector in Cartesian form by listing the coordinates. So we can let the coordinate x and y. It will be assumed that it will be the end of the vector. So by saying that the vector is at 5, 5, we will know that the 5, 5 means that x coordinate 5 and y coordinate 5. We can draw it from the origin and we will now have the vector. We can also analyze the position of a mechanism using a local coordinate system, meaning the x and y axis is no longer the vertical and the horizontal lines. We can have our own x and y axis depending on what the situation gives us. So for this example, we will use the red x and y axis as a reference instead of the global coordinate system, the x and y axis that are color black. It will also have its own coordinates and its own angle of inclination with respect to the x-axis. And that's the position analysis using reference with the coordinate system. If we will use local coordinate system, we can interpret the coordinates in global coordinate system using the coordinates in local coordinate system. So these are lowercase x and y. These are the coordinates at local coordinate system. This angle phi is the angle of inclination in the local coordinate system, and we can have the equivalent on the global coordinate system by following these equations. Then we have displacement. Displacement is the shortest distance of a point from its origin, regardless of its path. So the path is the distance traveled, but when we say displacement, it's the displacement, it's a distance or the shortest distance of a point from its origin. So in this case, it originated at A and ended at point B. So its displacement is BA. And if we have to analyze it, we can place a vector here. We can derive components using the coordinate system. So that's the displacement analysis. Then uh, next topic we had instant centers, but I will more go into that at the centro method of velocity analysis. Next is the introduction to velocity analysis. For the introduction to velocity analysis, we have to identify which parts of the mechanism are we analyze its velocity. We have two or more points on the same body. We have points on two or more bodies connected by pin joints, point on bodies on rolling contact, points on bodies on sliding contact. So these are the points that we can put analysis on velocity. In velocity analysis, we have four methods. For today, we will discuss the resolution and composition method. Then by the following week, after the design plate, we have instantaneous axis of velocity. Then we have centro method. And lastly, we have relative velocity. Or we will have our design plate number 2. We will have our design plate number 2 after the velocity analysis. Okay. Scales. Again, we have three scales to use here in our machine elements. First is the space scale, which is designated by K sub S. We have the velocity scale, which is K sub V, and acceleration scale, K sub A. The space scale is used in determining the size or the dimensions of the mechanism itself when drawing it on paper. So there's a representation. It can be full scale, smaller scale, or larger scale. So for full scale, the actual size of the dimensions of the mechanism or the machine part is the actual size in the paper. On smaller scale, we can have a large mechanism or a large machine be drawn on a paper on a smaller proportionate size. On a larger scale, we can blow up a small machine member or a small machine or a small mechanism member into a larger scale. Then that's the space scale. Then we have the velocity scale. So velocity scale and acceleration scale pertains to our vectors. Because we will be placing vectors on mechanisms, we have to address or dictate what is our velocity scale. So for example, if we have 1 inch of a vector, and we will say that this 1 inch represents 5 feet per second, it means that for every 1 inch that we draw a vector, it will be 5 feet per second. So for example, if we have a point where its vector is 2 inches long, meaning it has 10 feet per second. In the case of acceleration, that's also the same way. We will use acceleration scale in addressing the value of the acceleration through vector. So if our vector is 1 inch in the drawing and we say that it is at acceleration 100 feet per second squared, meaning if we have 2 inches of vector with this kind of acceleration scale, it will have 200 feet per second square acceleration. So example for this one, if we have this kind of link, this irregular shape link, we have points of interest at Q, C, B, and A. We can deduct that velocity at C is smaller or lower than velocity at B because the vector is shorter. So if they have a velocity scale of, let's say, for every 5 mm, and they have 10 meters per second, if this is the velocity scale, we will have to measure this velocity c, this vector, using a ruler. And when we measure the ruler and it comes off that this velocity c has 7 mm, for example, if it has 7 mm of vector, we will just multiply it with the velocity scale. So velocity c is equal to 7 mm times 10 meters per second over 5 mm. So again, this velocity scale is given by the designer. So it depends on you. It may depend on me depending on the exam. On the exam, definitely I will give the velocity scale. But for the design plates, you will have to decide on your own. So this one, then when we multiply the velocity c to the velocity scale, cancel the unit mm, and we will have 14 meters per second. So if we want to have the velocity at b, we have to measure it using a ruler. For example, we measured here 10 mm, and we will just have to multiply it by the velocity scale, 10 meters per second over 5 mm. Then we will have the velocity at 20 meters per second. So cancel unit. 10 times 10 is 100 divided by 5 is 20. And lastly, for velocity A, it's the same way. If we have a velocity scale of 5 mm is to 10 meters per second, you just have to measure the length of the velocity A using a ruler. And if it comes off with 15 mm, we'll have to multiply it with 10 meters per second over 5. And this will have 30 meters per second. So that's how we do velocity analysis. We will have a mechanism, we will have a link where the vectors are applied on it, and we'll just have to measure the velocities at these vectors. So that's the introduction to velocity analysis. We now go to what we call the first method, or one of the methods in velocity analysis. The first method is what we call the resolution and composition method. So this is familiar to us because on vector operation lecture, we already had the terms resolution and composition. So for resolution and composition method, given a vector, we can resolve it into two other vectors, or having the two vectors resolved into one resultant vector. So this is one of the example. If with the given vector, if we are only given vector A, how do we determine vector B? Using resolution and composition method. So by observation, we can see that vector A here has components. You can see on this blurred picture that we have this vector VA, then we have another vector here and another vector here. So using this vector, we can determine what is the vector at point B. I will show you later how this was performed. Again, this is the resolution and composition method. So what we have to do, is determine how to identify these vectors using the resolutions and the compositions of the other vectors. So I will give you uh, precise instructions. I will use my magic tablet. Share screen. Hi. For the example on earlier given, for example, we have, oh shit. If we have point A here, and we have point B here, and the only given is vector A. For example, vector A is here. For example, this is 2 centimeters. Oh no, what's happening? Let's say this is vector VA, and let's have the given. The given first is the velocity scale. The velocity scale given is for every 2 centimeter, let's say 1 centimeter. For every 1 centimeter, we have 5 meters per second. And velocity A is given to be 10 meters per second. Now, if velocity A is given and there's a given velocity scale, we have to represent this velocity into a vector. So how long is the vector of VA? So we will have it by multiplying the velocity with the velocity scale. So multiplied by the velocity scale, which is 1 centimeter is to 5 meters per second. So cancel second, the remaining unit is centimeter. 10 times 1 divided by 5 is 2 centimeters. So meaning, if we will draw 10 meters per second into the space diagram, it will be 2 centimeters long because the given KB is 1 centimeter for every 5 meters per second. So now I have drawn 2 centimeters on the space diagram. Next is determine the velocity at point B. So how do we do that? First, let's see what is given at point B. Point B is given its location. It's on the same link with point A. But also, it was given that the direction of point B is going this way. If the direction is given, but the magnitude is not given, so it's not a vector. So here, it's only the direction which is given. So now we have to find the vector of this point B. How do we do that? The first step is connect the line, the 2 points. using a line. By connecting this, use a ruler and make a straight line that will cross these 2 points. So at these 2 points, we have now a reference line. Then we will have to resolve this vector into components. What we will have to do is make a perpendicular line that will intersect the end of the vector. So from this black line, this line that connects the A and B, we will make a perpendicular line that reaches the end of vector VA. Then it has to be perpendicular, and the intersection point here, this intersection point will be the end of the other vector. So for this one, once we made this vertical perpendicular line, this is already the first component vector. Then for this one, we have from the origin going to the intersection point, I am not using the ruler. Huh? Oh no, I'm so bulok. There you go. Then once we have this intersection, we will have the other vector. So we have resolved the given vector into two vectors. The first one should be perpendicular to the line, and the other one is along the line. Okay? Then, the first step is to connect the 2 points using a straight line. So I used this black line to connect A and B. Then, we will have to make a perpendicular line to this connecting line going to the end of the given vector. Then, once we have that, we will have the vector along the line here, and we will now have the two vectors. Now, using these two vectors and applying it to B, we will have to copy the vector along the line. So we will have to measure how long is this one. Using a ruler, let's measure it. So we have at least 2.2 centimeter, I think. Okay, so let's draw 2.2. So from this point going here, so it's this one. As suggested by statisticians. Okay? So therefore your eye would be equal. Again, by determining the length of the composition here, I measured 2.2 centimeter. Then I will copy it here. So this is also a vector with 2.2 centimeters. So once it is copied, we will also make a perpendicular line. So the perpendicular line here is not copied, only the along the line. So we will have to make a perpendicular line from the end of this copied vector. So the question is it a perpendicular line going up or going down? So for this example, since it's given that the velocity of point B is going here, the direction here is at green line, we will have to make a perpendicular line going into the direction. So for this example, we will have to make a perpendicular line from the end going to the direction. Again, this green line is given by the problem, given by the situation, that the direction of point B is along this green line. Then we made a perpendicular line going down because it goes to the direction given. Then we will make an arrowhead for the vector. And now, this intersection point of the direction and the perpendicular line is the end of vector B. We will just have to trace this line from the origin going into the intersection point B. They will now be velocity B. And for the final, to determine the velocity B, we will have to use a ruler again to measure its length. So which one will we measure? This one and oh. Alright. So let's measure the length of this one. So this is around again. Okay. Wait. So if velocity A is given at 2 centimeters, we will have to measure velocity B, which is given at 2.3, I think. So if velocity B is measured to be 2.3 centimeters, we will just have to multiply it with the velocity scale, which is given by 5 meters per second over 1 centimeter. Cancel the centimeter. 2.3 times 5 is 11.5. So this is how we perform the velocity analysis. So again, resolution and composition method, by having given the velocity A, 10 meters per second, and given also the velocity scale, having given the velocity A at 10 meters per second, and also given the velocity scale of 1 centimeter is to 5 meters per second, we will know how long we will draw velocity A. We have to multiply the velocity A with the velocity scale, and we arrived at 2 centimeters. So I drew the 2 centimeters in the figure. Next, identify the given at point B. Given at point B is the direction given here at the green line. So this is given references. Then if we now know where is point A and point B, the first step is to connect this line. So this black line is the connection of A and B. Then once we have connected A and B, we have to determine the components of velocity A. So vector VA can be resolved into components by having the perpendicular line with the black line going to the end of vector A. And it's along the black line, we will have to make a vector again going to the perpendicular line. So once we have this line, this vector at the black line, we will only measure it and copy it to point B. Once we have copied it to point B, we will make a perpendicular line also at the end of this copied vector. So we know that it will go down because the direction of velocity B is going down. Then it will intersect on the direction sense of velocity B, and their intersection will be the end of vector VB. Then we have to draw the vector VB and measure its length. So this is what I did. And once I measured it, I came up with 2.3 centimeters. Then we will have to multiply it with the velocity scale, which is 5 meters per second per centimeter, and cancel the unit centimeter. We will arrive at velocity v is at 11.5 meters per second. Ang hirap pala, sir. Nakalito lang siya man kasi first time niyo makita. Pero pagka ginagawa niyo na siya, yan, maintindihan niyo na siya. Any questions sa steps? Dun sa steps by step, I would suggest na itanong niyo talaga yung step by step. Kung hindi niyo naintindihan, huwag kayo mahiya. Kilala niyo naman ako. So kung nalito kayo, may part na hindi kayo maintindihan, sabihin niyo agad. Kasi okay isang sa akin magpaulit-ulit. Ang mahalaga, maintindihan niyo. So any question on this clarification on how to perform resolution and composition method? I-stress out ko ha. Huwag kayo mahiya ha. Hindi naman ako mainipin ha. And if kung may kilala kayo na master na nag-take sa akin ng machine elements, sabihin nila sa inyo, inuulit ko talaga yan kahit isa lang yung nagtanong. Yes, pagdating sa exam, magdodrawing kayo. Ganyan din gagawin natin. Mas mahirap nga lang, syempre. Madali pa yan, dalawa lang yan eh. Kaya, magdadala ng... suggest ko talaga magdala kayo sarili ng pan-drawing. Kasi pag nakita kayo ng proctor naghihiraman, wala na. Mamarkahan na nyo yung papel nyo. Okay. If walang question, let's get another example ba? For example, we have this one. If we have point A here, point B here, and we have point C here, and given velocity A is, wait, check ko lang kung di ko ba. Lipat ko lang point A, masyadong malapit. Okay, tapos level neto ay hindi sumama. Lagay ito dyan. Then point B ba? Okay. Okay, pwede na yan. Okay. Problem. Determine the velocity at B, point B and point C, given that the velocity A is a vector. Let's compute. If we have, for example, if we have velocity scale at 1 inch, oh, it's putol na. For every example na, for every 1 inch, we have 10 feet per second. Then we have velocity A at 10 feet per second. So, how will we draw, how long will we draw velocity A? We multiply it with the kV. For every 1 inch, we have 10 feet per second, cancels feet per second, and 10, we have 1 inch. So let's draw 1 inch for velocity A. So for example, it is given that is going in this direction. Eh, masyadong malaki ba? Hmm, okay, for example, this is the 1 inch. So this is velocity A. What's more given is velocity B is going in this direction. Again, this green line is given. What we have to find out is what is the velocity at C and velocity at B. So I'm using the lowercase letters for velocity, but the uppercase letters at the points. So again, determine velocity C and velocity B using these given ideas. Okay, first let's determine velocity B. First step, let's make a straight line by connecting point A and point B. And this straight line will be our reference in the velocity analysis. Ayusin ko lang yung arrangement niya ba. So, kailangan ba may iPad para pumasa? Hindi naman. Mas pogi lang. Kasi sa papel naman tayo magdodrawing. Okay. First, let's solve for the components of velocity A. So if we have velocity A, first we'll have the perpendicular line from the black line going here. So this is the first vector. Then the next is from the black line for the along the line. Let's go from point A going to the perpendicular vector. Then we have to measure if we have the vector A at 1 inch. Wait, I'm just trying to find the 1 inch. Alright. We will have to measure the vector below. So it's 0.9 inch, 0.9. I will have to copy it here at point B. 0.9, 0.9 ba? Okay, so I measured this at 0.9 inch. Paano nyo ginawa yun, sir? May ruler. Kopya ko lang to dito ba? Yan. Tapos pag kinopya ko to ba, dapat pareho sila haba. Kopya nga eh. Then, when we have this, since given that the direction of velocity B is going downwards, we will make a perpendicular line going downwards. So this perpendicular line from this point going here, it will intersect at the direction. This is now the components of vector B. So determine the vector B, we will have to connect the point B going to the perpendicular vector. This is now velocity b. So to determine the velocity b, we will have to measure it again using a ruler. Okay, so let's measure it. How long? 1.6. So if our measured velocity b is 1.6 inch, we can compute again using velocity scale. The velocity b is equal to 1.6 inches times the velocity scale, which is for every 1 inch, we have 10 feet per second. Cancel inch and velocity b, we will have 16 feet per second. Dali nung computation, di ba? Pwedeng mental math eh. Yeah, the computations at here at Machine Elements for this one is very basic. And the only challenge here is where to draw, where to measure. So that's part of the Machine Elements. So now we have velocity b. For next, we have to determine velocity c. So how do we determine velocity c? Velocity c can be determined using velocity a and b both. Because unlike point b, velocity c has no given direction. So we determined velocity b because the direction, this green line, was given. But at point c, the direction is not given. So how do we determine velocity c? So we can determine velocity at point c by using velocity a and velocity b. So let's take a quick shot. Ito bang ginawa ko scratch? Gusto niyong kopya kapag katapos ng lecture?
Yes po. Opo.
Okay. Paano bang gawin kung maganda? Kasi de-delete ko yung ibang parts eh. So screenshot muna natin. Ay, bobo mag-screenshot. Nag-home. Tawa kayo dyan na yun. Yun. Okay. Kasi delete ko muna yung bang part para hindi tayo magulo. Ala, hindi na ito ma-delete kasi na home ko. Sabi na nag-fix na siya kapag ka nag-home. Ben? Anyway, magawa na lang ako ibang kulay para hindi malito. So to determine velocity at point C, like how we determined at velocity at point B, we have to first connect those 2 points. By connecting them, let's make a straight line, point A to point B. Then, the previous compositions that we determined, this one and this one, cannot be used for point C because this composition was used at point B. So we cannot use it going to point C. So we will have to make another set of compositions. So now we have a new composition from this black line. We'll have to make a perpendicular line. Okay, that's one. Then we'll have to make a component here along the black line.
or frequency. So instead of doing adding and adding, so I just put it in the formula. That
Then we will have to
frequency
measure
will
it
be
again.
equal to this cumulative frequency or the lower class or the highest class.
So I'll just copy here.
Okay. And you ended up with the last, which is how many of your data are greater than -0.5. So all of your data, because the
1.3.
lowest is 6, it's higher than -0.5. So all of them are greater than. So you have the.
Okay. So this one, I copied going here.
Okay, so we are done with this table.
Now, for this, the following uh, part of this resolution and composition method, we need to make a perpendicular line with reference to this component for this vector. But the challenge here is that we don't know the direction. Unlike earlier at point B, we have a given direction, which is this color green line. So we know where to put the perpendicular line, this one, going downwards.
Okay.
So we know that this is going downwards because the green line is going downwards. But for this point C, there is no given direction. So for now, let's stop at where we were this point, and let's proceed in determining velocity C using velocity B. So again, let's make a straight line by connecting point B and point C. And making also components of the vector VB. So our vector, we will not use this and this one because these components are used with reference to point A. So we will not use this one. What we will use is to make another set of components from the perpendicular going to, yeah.
And you can graph also the other one.
Then once we have the perpendicular, we will have the component from point B going to,
But the other one, if you graph this other one, the greater than the frequency, it should be the other way around. So it is
the perpendicular line, and this vector will also be copied going to point C.
that is Ojai. Now we go to the discussion that we have on the we will be utilizing the same.
Okay, so let's copy here.
Go back to
So we now have other components. We have components of velocity C with reference to point A. We have components of velocity C with reference to point B. Now, they are both going down. So we can assume that the velocity C is also going down. So meaning, when we make the perpendicular line here, it must be going down. Then if we have the component at the other from the other component, it must be also going down.
and then you divide it by n. So later we will show it by itself. That is called the log method formula. The other one is called the coding method.
And we can see that these two perpendicular lines is intersecting at one point, and this intersection can be assumed to be the end of vector BC.
Product of the frequency and
So this is now your velocity C.
wherein
Okay, again,
like unification of plus mark
using velocity A, we have copied the component
and A
to
is
point C. Using velocity C,
let us
using velocity b, we have found the component for point B and we copied it to point C. Now, when we copied it to point C, we will now make the perpendicular lines, and since they are both going down, we will make the perpendicular lines going down also. So these perpendicular lines will intersect at one point, and their intersection will be the end of velocity C. And this is velocity C. Now, let's measure it using our ruler.
Let me use the first method of it. It says there that
Okay.
you have to
Then,
find
the measurement of velocity C is 0.6. Let's say it's 0.6. 0.6 inches multiplied by the velocity scale, 10 feet per second over 1 inch. Cancel inch, we will have velocity C at 6 feet per second. So we now have the given velocity A, we have computed for velocity B, and now we have computed for velocity C. So that's the purpose of velocity scale. And now you have seen its application. Again, is there anyone who would clarify the step or the procedure I showed you, how to perform the resolution and composition method? Ito, paano pag sa exam, magkaiba kami sukat? Kasi nangatal ako nung nag-ruler. So we have considerations. If your final answer will be close to my final answer in my answer key, it can be accepted. Pero pag ang diferensya natin ay kalahating centimeter na, naku po. Pagka dapat 5 cm ang nagawa mo 3 cm, malaki nung diferensya yan. So pagka halimbawa, mga 4.5, yan, pwede pa yan.
Okay, next, the second method.
Again, any question? Gusto mag-repeat ng steps?
The assumed plus mark or the assumed
Yes, Alvin Anthony Barola.
Sir, excuse po.
Danica?
Dun ko po ay dun po sa sa mga VA at VB po. Diga po ang yun pong yung pong 1 inch dun po sa VA ayun pong pataas.
Yung blue.
Alin po, sir?
Itong blue.
Yan pong blue. Ay, paano po nakuha ang angle niyan, sir?
Given yan, given.
Okay po. Doon po sa VB. Given din po.
Ang given sa VB is itong kulay green.
Green po. Okay po. Alin po yung 1 inch, sir, doon po sa sa VA?
Yung kulay blue, yung haba ng vector VB. VA, yung haba ng vector VA.
Tapos i-connect lang po yung mga red.
Parang mangyari. Kasi given natin, ang velocity A is 10 feet per second. And ang velocity scale natin is 1 inch is 10 feet per second. So, kinonvert ko muna siya to inches, kaya naging 1 inch. So, ito yung 1 inch na ito nakalagay dito. Ngayon, pag na-draw ko na siya dito ng 1 inch, yung angle niya, given yan, kaya ako nilagay dyan. Pag-connect muna natin si point A at si point B. So, ito yung black line na to. Ito yan, yung pinag-connect ko na yan. Then, pag may connection na, ito na yung reference line natin para magawa itong components niya. So, dito, nagawa ko ng perpendicular line dito sa black line natatama dun sa dulo ng vector BA. Tapos, from point A, ito yung point A natin, maggawa ko ng vector din na tatama dun sa dito sa vector na ginawa kong una. So, nagkaroon ako ng vector na itong nakahiga. So, nagsimula yan lahat dun sa vector BA na blue. Tapos, gumawa tayo ng black line na connection ng point A at point B. Then, gumawa tayo ng perpendicular line dito sa black line na tatama sa dulo ng point A ng BA. Then, gawa tayo ng vector uli from point A papunta doon sa perpendicular line. Tapos, yun yung sinukat ko naging 0.9 inch ba? Then, kinopya ko pa dito sa point B para magamit ko siya sa point B. Nag-height ka na ibig sabihin, mas nagets ko siya ngayon. Nasagot ko ba ikaw, Alvin?
Yes po, sir. Thank you po.
Thank you din pagtatanong. Gusto kayo, natututo kayo Okay, so we have bunch of examples pa. So this is a basic example kasi nasa space diagram pa lang tayo. But we'll have an example pa. But for now, since naka-isang oras na tayo sa lecture, pahinga muna tayo ba? Huwag tayo ma-overload. Pahinga lang tayo ng kahit 18 minutes. Wait lang. 8:50 ba? 8:50. So that 28 minutes. Kumain muna kayo. Padalhan nyo ako. Ay, nagpa-cake na pala kayo. Maraming salamat. Napakasarap ng cake nyo. Di na ako namigay sa inyo kasi magkaingitan lang tayo. Okay. Let's resume at 8:50. Let's have a morning break and I'll see you later.
The formula is your assumed mean, which is 49, plus the class interval or the class size of 9 times this summation the median class now in our Excel file. So N is the total number of observation, which is 30. Then you have the cumulative frequency F. The cumulative frequency of the class preceding or before the median class.
Hi, Lucel.
If
Nandiyan ka ba,
found the
Lucel?
median class, you look at the cumulative frequency before that, and that is your average.
Yes po, sir. Bakit po?
I agree with the
Sino-
class interval of
Gets ko naman yung
size,
AU, yung
and
AU.
F sub n is the frequency.
Pero, sino nakaisip ng get-get?
Okay? So,
Sir, tignan nyo na lang yung member. Sino sa tingin niyo po ang nag-isip?
all over.
Ay, nakaba sa aking.
Go back to our,
Si Sakik agad. Tama ba ako? Tama ba?
Opo, sir.
Absent ka talaga ngayon. Kapag ko pa sinasabi.
So, the median class is where the n over 2 observation is located. You have to look here in the cumulative.
Pwede ba mag-commercial dito?
Doon natin makikita kung nasaan ba ang ating 15th observation. It is here. Ano? Ito yung ating 15th observation. But do not be confused that it is written directly as it is.
Ay,
What if I made this to be 8? Now there is no 15. But what does this 16 indicate? This 16 indicate that starting from the 9th to the 16th observation is
Okay, commercial.
and therefore that would be your median class. Okay?
Bili na po kayo ng damit nila. So sa, I think, RM 280 ta, no?
Which means that in the first class,
Opo. Tapos palagay po ako sa referral. Thank you po.
Alagay mo ano, referred by Sir Dong. Wag Russell.
So this 15 refers to the 9 to the 15.
Okay, so yan. Meron siyang blue at white variant at may baybayin siya. Yung
Where is
matatag.
now the median class?
And, yan.
If that is 6,
If you are like,
it means that
nag-release na ng Google Form si RM para dyan.
data it is
Commercial lang.
on the 27 to 35 plus because this 18 refers to 15 to 18 data.
Sap na po sa memento ng MES, sabi ni Ernest.
Because we must be thinking
Ano yung memento? Damit din?
the n over 2. Okay, so there is 15. The 9 to 15 data are located in this class.
Buti nga yung, ano ito, 80 lang. Ito yung suit ko, ano to eh. Ano ba to? Sa National Convention to ng PSMA. Makalagay ba? Meron ko nakasulat eh. May nakasulat ba sa likod? So sa National Convention ng PSMA, 800 daw to eh. Sabi ko, presyo 800 ba to?
Okay, so L plus the quantity.
Pero libre ako dito eh. Kasi sikat ako sa PSMA.
So N over 2 is 30 over 2.
So libre lang to sa akin.
And the cumulative frequency
Anyway.
of the class preceding. No? So you have to look here. Ano? This is our median class. This is the cumulative
Okay.
frequency.
Inaalala ko lang kung ano yung gagawin dito.
It's the cumulative
Check ko lang dun sa
frequency of the class
figure.
preceding.
Okay. Naalala ko na siya.
Okay? So this is the median class. So just look
Parang
at
nilalamig.
the F
Ang lakas sa aircon din eh.
or preceding.
Parang kailangan ko ng hug.
That is the
Yung,
value of the advertisement. And then the F sub F is the 7, the frequency of the median class. Okay? Let me take the formula of the value of our median. The median would be equal to the lower class boundary, that is 17.5, plus n over 2, so that would be 30 divided 2 minus the cumulative frequency of the class preceding it is 8 divided by the frequency of the class which is 7. And then we multiply it with, we multiply it with,
Excuse me.
okay, so the median is
Okay, for this example naman, what if we have velocity A, lagyan na ng values.
check po the value, kung tama.
We have velocity
Then
A
is equal to the lower
is
class,
equal to
boundary
20 meters per second.
and over
And ang ating velocity scale
minus
is
the
given
boundary
at
frequency of the class
sa
preceding it,
1
which is
centimeter
so 15
ay meron
minus
tayong
8 is
10
7.
meters per
So
second.
divide it by 7. So that
What
is
if ganito naman yung given?
multiply it
So
by
first,
10.
let's
So
determine
7.5
velocity A, kano kahaba yung vector niya. So multiply natin si velocity A
that is
with the velocity scale
means that
na 1
50%
centimeter per 10 meters per second.
falls below
Then cancel yung meters per second, we will have 2 centimeters. And what if given that velocity A is
Question, clarification,
here.
please.
So let's make 2 centimeters like that.
There po ba yung median? Okay. Then I proceed to move.
Okay? Again, ito yung given. What is velocity A?
As we define,
Given is velocity A.
is
Ito
the
yung direction niya. Then yung isa pang given is velocity B. Ganito yung direction niya. And ang tanong dito, determine velocity B and velocity C. So, ano yung velocity sa point B at velocity C? Ang given lang na direction is velocity B. So, how do we do this?
Okay. So this is the
First,
formula for
let's
mode
determine
for
velocity B.
So
And
for ungroup data,
again, ang first
look at the
step
mode.
natin is draw a
Here
straight
also,
line.
you have to look first for the mode.
Let's draw a straight line from
What
point A
is
to
the
point B,
modal
like this
class?
one.
So the modal class is the class with the highest
Then,
frequency.
from this point,
And you will be computing
gagawa na
the
tayo ng
equal to the
components
lower
ni
boundary
velocity
of
A.
the modal
So,
class
to make the components,
plus V1 over V1
let's make a
plus V1
perpendicular
plus
line
I. Now what is V1?
from the
V1 is
straight
the
line
difference
going
of
to the end
frequency
of
the modal
vector
class and
velocity
the
A.
class preceding it. And V2 is the difference of
Then, pag meron na tayo nitong
the
perpendicular
modal
line,
class and the
gawa naman
class
tayo ng
preceding
vector
it.
from point A going to the perpendicular line.
Lower boundary plus V1 over V1 plus V2. Ang V1 po natin is preceding class and V2 is
Yeah.
the succeeding.
So, meron na tayong dalawang vector. Nakuha agad natin yung dalawang vector.
Okay.
Ang next natin gawin, sukatin natin gaano kahaba yung ating
The median of the given data. Okay.
Yeah.
Sorry, the
So,
mode.
sukatin natin gaano kahaba itong component niya dito sa line na to. So, sa line na to, we have
Alin po ang modal
1.1.
class natin?
So, sa 1.1, drawing din natin siya sa B.
Which has the highest frequency po? Which class?
Okay, let's, then, nung sinukat ko siya,
Okay,
ito ay
so
1.1
826
centimeter.
is also
Then,
your
ikakopya ko lang siya dito sa B, 1.1 centimeter. Then, since given yung direction ng B, alam natin kung saan yung papunta yung ating vector na perpendicular. Papunta siya sa baba.
But if you use our formula,
Wait, ibahin ko lang yung direction ba?
to ating lower class boundary, which is 17.5. And plus height for the other. So that
Gawin kong ganito. Kunyari, dito yung direction niya. Okay? Then, drawing natin yung perpendicular na pababa. Galing dun sa kinopya nating component ni A.
Ang B1 po natin ay 7.
Meron na tayo ngayong components ng vector V. Nag-intersect siya dun sa direction, meaning, ang ating velocity V ay from this point going to this point.
7 minus 4
Ito na ngayon si velocity V.
minus pa plus ang formula.
So, yan ang ating velocity V. Madali na siyang gawin. Madali na. Intindihan na natin eh. So, let's just copy the component from the line to point B. this one. Then let's make a perpendicular component going to the direction of velocity b. So that's it. We now have to measure velocity b. If velocity a is 2 centimeters, let's measure b. We have 1, 2, 3, 4, 5.9. Let's say we have velocity b at 5.9 centimeters. Let's multiply it with the kV, which is 10 meters per second over 1 centimeter. Cancel unit centimeter. We now have velocity b at 59 meters per second. And for velocity c, no direction was given. If you can remember our previous example, we used velocity a and b to determine velocity c. But for this one, it's a different case because we can see that point C is along the line of A and B. They are collinear. So if they are collinear, we can make a proportionality. What do you mean? What do you mean? So first, since they are along the line, I can also copy this 1.1 centimeter to point C. Again, I can do this because they are on the same line. So let's just copy 1.1 here.
Okay, another question is, ma'am,
So this 1.1 from the component of velocity A of vector VA can be copied to B and C because they are all at the same line. Unlike this one, point C is not on the same line, so I had to make another set of components just for point C. But for this one, since we have those 3 points at the same line, I can copy the components to both points. Then, what proportionality am I referring to? So, we know that the direction of vector VA is going down. We know that the direction of vector VB is going down. And since they are all on the same line, we can assume that vector VC or the velocity of C is also going down. So meaning, we can make a straight line from this, which is perpendicular. But we still don't know how long it is. We just know that it's in there. We just know that it is perpendicular. We know that it is going down because the other points are going down. And they are on the same line. Then, we will have to make a proportionality line. So what is a proportionality line? It is only applicable when points are on the same line. So like this one, point A, B, and C are on the same line. Let's make a proportionality line. A proportionality line is made by connecting the arrowheads of the other vectors. So the vector, we have vector A and vector B. Let's connect their arrowheads. And it means that the arrowhead of velocity C is also in this proportionality line. Okay, I will repeat. When points are on the same line, it means the direction of the velocities of them are all the same. And when we make a proportionality line, we have to connect the arrowheads of their vectors. So when I connected the proportionality line to vector VA and the vector VB, it means that vector VC is also in this yellow line or this proportionality line. And we can see that this proportionality line intersected with the perpendicular component of vector VC. Meaning this intersection will be the arrowhead of velocity c.
Either the lower or the upper class boundary, depending on if you are talking of the greater than or the less than. Then you put on the y-axis the frequency, the cumulative frequency, and then you join the 2 points by
So this is, we now have the velocity b and c. Okay? So this method is only applicable when points are on the same line. So again, let's measure. If we have velocity a at 2 centimeters, we have velocity c at 1, 2, 3, 4. Velocity c is equal to 4 centimeters multiplied by our velocity scale, our kV. And for every 20 meters per second, we have 1 centimeter. Cancel the centimeter unit. And now we will have 80. Wait lang. Tama. Parang mali yung ginap. 10 lang pala. Grabe naman yun. We now have 40 meters per second. So this is VB and this is VC. You can see how we are following the rules of the vector, meaning the longer the line, it has more magnitude. So VB has a longer vector because it has 59 meters per second. It has higher velocity than the others. So any clarification for this example? Okay, one more example. Let's have this one. Commercial again. I'm just looking at the calendar. So our next face-to-face meeting will be on September 15. And the next one is September 29. Huh. Okay. September 15, we will have design plate number 1. September 29, we will have design plate number 2. I think. Then October 14 is lecture. Okay. So for this example,
even the M I should select.
This one is pretty complicated.
You try it now.
Pretty? What if we have point A,
Okay.
point B, point D, and
But actually,
let's change this
what
color.
I want to show is you can actually have here on the x-axis the class, but since it is a histogram, we can actually use the class mark. Okay, kung class mark yung pinaki natin.
And we have point C.
The polygon kasi.
So we have to determine the velocities of
when you connect the middle portion
B, C, and D, given velocity A is equal to, let's say, 5 inches per minute. And the velocity scale is, let's say, for every 1 inch, we have 2.5
I will try to explore
inches per minute.
how we can use it.
Okay.
Last time I had
So first, let's determine how long VA is. So VA, we multiply it with the KV. When we multiply it with 1 inch over 2.5 inch per minute,
So when you graph the
cancel inch per minute, we will have VA is equal to 2 inches. So when we draw VA, we will have 2 inches vector.
sorry, last one on the exam.
And let's have them given at 45 degree. So if vector VA is this one,
And then you connect it with line segment, then you put it in the frequency point. I had it already last time. I don't know, I graph it with that
if we have 2.5 inch at vector VA, 2 inch pala. Nalito naman na.
Okay, anyway, that can be done.
If this is VA, determine velocity B, velocity D. So, in this example, we can also apply what we did earlier. So what we did earlier, I made a direction sense on B, then made a proportionality line, just like that. For this one, the direction sense is not even. So how do we determine the velocities at point D and point B? Wait, baliktad pala yung point.
Okay po. Do you have any other questions or clarification with this?
At itong pinakita ko sa inyo, ito nasa lecture din naman to na in-upload ko sa classroom.
Question, clarification?
So, dito, pinakita ko lang sa inyo paano siya nabuo. Pero, yung actual na itsura niya, makita niyo siya sa yung in-upload ko ng mga PowerPoint. Okay. So, for this one,
Okay. Question po, clarification na?
we can make an approach by
Okay. That question then. Yeah.
wait. Making the component vectors.
The class interval or the class size.
So we have AD and B.
Okay, the class size
We make
of
the
class interval I is
straight line
computed as
here
the range
to make the perpendicular one.
divided by the assumed number of classes.
Then we have this component.
Okay, range is equal to the highest score minus the lowest score. Okay, and the assumed number of classes.
Then let's measure this one.
20,
How long?
depending on the nature of
It's
In our example,
1.3,
we chose,
I think.
guidelines are already
So let's
discussed
just
on how
copy 1.3 to
assume
D and B.
with this. So when we try to compute for this is equal to 9 minus 6, which is 93, and this is 10. So the answer is 93. And based on the suggestion, we should be putting it as an odd number. Since our data are all full numbers, so might as well that our class interval or class size is also a whole number.
Okay. So this one we measured to be around 1.3 inch. At may eye, ano ba naman yan?
Questions or clarification?
Guys, yung sinasabi ko kaninang get out, comment na sila nung group members nila tsaka members ganun. So yung iba, paki-comment na rin yung groupings. Then this 1.3 will be copied here and also will be copied here. So that's why this is also 1.3 and this is also 1.3.
all about the distance.
Then, since velocity A is going upwards, spaghetti pataas ba siya ganun? Pag spaghetti pataas din itong iba.
Previous class data.
Itong gawa natin siya. Yun. Pero dito ba? But here, you don't know how long is the vectors. So what we can do is make a proportionality line again. But the difference here now, because previously, we made the proportionality line because we know the direction of point B. But now, we don't know the direction of point B. So we have only one given vector, which is VA. So how do we do the proportionality? We can do the proportionality by starting at the pivot. So at this example, the pivot or the joint is given at Q. So using this Q, we can make a proportionality line going to the vector VA. So that's the proportionality line. Again, the difference in this example with the previous one, in the previous one, the direction of point B is given, which is going downwards, while this one is given the pivot, not the direction. So now, these intersection points, this one and this one, so these intersection points will now be the end of the vectors at point D at point B. So let's just make a vector originating from point B going to the intersection. And once we have made this vector going to the intersection, this will now be velocity D, and this will now be velocity B. So that's our vector. Our next step is to measure these vectors using our ruler. Velocity D is at 1.9, around 1.9. So if velocity D is equal to 1.9 inch, we have to multiply it to our velocity scale, which is for every 1 inch, we have 2.5 inch per minute. And the product is, kayo naman, bulok mag-multiply. 1.9 times 2.5. 4.75 inch per minute. So that's the first example. Then for velocity B, we have to measure it again using our ruler. How long is it? So it's around 1.5. So if velocity B is equal to 1.5 inch, let's multiply it to velocity scale. For every 1 inch, we have 2.5 inch per minute. Cancel inch. We will now have, ano sagot dito ba? 3.75. Mental math lang yan. Tama ba yan? Yung mental math ay kakalkyo din naman eh. Ulit. 1.5 times 2.5. Yeah, tama. Galing talaga. Okay. So we have now velocity C. So we have determined velocity B and velocity D using the proportionality line. Again, the difference with this example from the previous one. From the previous one, we have the direction sense of velocity B. But for this one, we don't have the direction sense of the other points, but we have the pivot, which is Q. And we can make the proportionality line starting from the pivot. Then, to determine velocity C, we have to project point C going to the lines ADB. What do I mean? We can see that point C has its pivot also at Q, meaning point C is related to points A, D, and B. I will repeat. Point C has its pivot also at point Q. So they are the same with ADB. And since they have the same pivot, we can relate point C to line ADB. So what we will do is we can have two methods. The first method, this is the easiest part. If we have a compass, we will use a compass to measure Q and A. But I don't have a compass because I'm using an iPad. Then, using Q and A, we'll just have to make a arc from C going to this one. So this is an arc using a compass. We will just project point C going here, line ADB. And we can do that. But if we don't have a compass, what we can do, we can use a ruler. Let's measure how long segment QC is. So from this example, we have 1, 2, 3, 4, 5, 6, 7, 8.9. If you have 8.9, you can project it to line ADB, which is 1, 2, 3, 4, 5, 6, 7, 8.9. So it's the same. Galing. Point C. Again, what I made here is to project point C to line ADB because they have the same pivot. So since now we have ADB, I'll just erase this one. This is point C now. We can also copy the 1.3 to point C. So let's copy 1.3.
Just any assumed class. Or old class. So number 4 will be
1.3.
after we discuss the measure.
So this is the 1.3. We can also copy here. Then, same thing, we'll make a perpendicular line going up.
Again, you use Excel sheet. You will be submitting to soft copy solution.
And the intersection of this perpendicular line
For letter B, never mind po.
with the proportionality line will be our end of vector
So
BC.
measures of central tendency lang po muna. As mentioned, you pick 25 data only. It's up to you which 25 data will be. And you pick the first.
So this is vector VC, velocity C. Then finally, we have to measure it using our handy dandy ruler. And the measure is 1.8.
First column.
So with velocity C is equal to 1.8 inch. Let's multiply it with the velocity scale. 1 inch is 2.5 inch per minute. We will have
Everyone access the file. Yes, sir, Raven.
4.5 inch per minute.
I will not ask
Okay.
you to submit.
So these are the determined velocities VD, VB, and VC.
So it would be
Okay, again, this lecture, I will share to you on our Google Classroom after this class. And does any have any clarification on the step-by-step procedure that I made for this velocity analysis?
Yes po. Okay, I can share it now po. Wait, I'll just upload it in the drive. I cannot do. Yeah, I think I can also send it to the.
Okay. If there's no more question, we'll have a commercial. What will happen now? So today is September 8th. Next week, we'll have our face-to-face class at Boiler Room again on Sunday, which is we will make the design plate number 1. So even though we have already moved past the subject matter, the position and displacement analysis, we will still make the design plate number 1 on that topic. Then on 22 lecture, on 29 is design plate number 2. Now for September 14 and 21, which is our Saturday session, I'm still thinking of our agenda. So I'll just inform Lucelle if we will go again for asynchronous or we will have an online class. So I will announce by later this week. For now, yes, think that we will have a class. Okay, so that's all. Thank you for attending the class. I hope you learned. And as you can see earlier, when someone asks, I am open to questions. So, yan. Russell, pastay na lang. May tanong lang, may kausapin lang kita ba?
Thank you po, sir.
Thank you.
Pwede na kayo.
Thank you po.
Thank you, sir.
Thank you po.
Thank you po, sir.